Good morning, students. Welcome to the software engineering course under Markout. This course will help you understand key concepts and clear your doubts regarding this subject. Stay engaged as we will be covering essential topics step by step. We will also bring another part soon to deepen your understanding. Let's begin.
It is an honor to be here today to discuss an essential software development approach, the spiral SDLC model. As future engineers, it is crucial to understand different development models to ensure the successful completion of projects. The spiral model is one such methodology that blends the best features of both waterfall and iterative models, making it highly effective for complex and high-risk projects. What is the spiral model? The spiral model, introduced by Barry Boehm in 1986, is a risk-driven approach that allows software to be developed in iterative cycles while continuously managing risks, instead of following a strict linear process like the waterfall model. The spiral model moves through repeated phases, refining the product with each cycle. Think of it like a spiral staircase. With every loop, you get closer to the final product while constantly evaluating and improving it. Phases of the spiral model. The spiral model consists of 4 key phases that repeat in cycles until the final product is developed: planning, gathering requirements, setting project objectives, and identifying risks. Risk analysis, evaluating potential risks, exploring alternatives, and preparing for challenges. Engineering, development, and testing, designing, coding, and testing the system. Evaluation and review, seeking feedback. Refining the product, and deciding whether to continue, modify, or terminate the project. Each cycle of the spiral refines the product, gradually making it more complete and stable. Some of the most critical factors in software development: objectives, alternatives, and constraints. Whether you are developing a mobile app, enterprise software, or a complex AI system, understanding these elements is essential for delivering a successful project. 1. Objectives. What are we aiming to achieve? The primary goal of any software project is to meet user needs and business requirements. But how do we define success? That's where software objectives come in. Some of the key objectives include functionality. The system must perform the required tasks effectively. For example, an e-commerce website must handle product listings, payments, and user authentication. Performance, speed, responsiveness, and efficiency are crucial. A banking app, for instance, must process transactions in real time. Hardware, software interface. The software should be compatible with the hardware and operating systems it is designed for. Imagine a game that runs smoothly on both Windows and PlayStation. This requires careful interface. Planning. Critical success factors, CSFs. These are the must-have elements that determine whether a project succeeds or fails. For example, in a healthcare system, security and accuracy in patient records are critical. Clearly defining these objectives ensures that the development team stays focused and aligned with business goals. 2. Alternatives. How can we build the solution? Once we understand the objectives, the next step is to explore alternatives to build the software. There are multiple approaches, and selecting the right one depends on factors like budget, time, and technical expertise. Common alternatives include build, developing the software from scratch. This provides full control but requires more time and resources. Reuse, using existing components or frameworks to speed up development. For example, many websites use Bootstrap for front-end design instead of coding everything from scratch. By purchasing off-the-shelf software if it meets requirements. This is common in industries like HR, finance, and customer relationship management, CRM. Subcontract, outsourcing development to third-party vendors. Companies often hire freelancers or software firms to handle specialized tasks. Hybrid approach, a combination of the above. For instance, a company might buy a ready-made CRM system, but customize it with additional features. Each alternative has its pros and cons, so teams must evaluate cost, flexibility, and long-term maintenance before making a decision. 3. Constraints. What challenges do we face? Every project operates within certain limitations, and these constraints can impact decision-making. The major constraints include cost, budget limitations. Dictate what features can be implemented. A startup may not afford an expensive AI-driven chatbot, so it might opt for a simpler solution. Schedule. Deadlines determine the speed of development. If an app must be launched in 6 months, the team may choose agile development for faster iterations. Interface compatibility. The software must integrate seamlessly with existing systems. A new banking application must work well with legacy databases and security protocols. Technology and skills. The team's expertise plays a crucial role. If developers lack experience in a certain programming language, they may need training or external support. Balancing objectives, alternatives, and constraints is what makes software engineering both challenging and rewarding. Conclusion. In every software project, defining clear objectives, choosing the right development approach, and managing constraints are key to success. By carefully analyzing these factors, we can deliver high-quality software that meets user expectations, stays within budget, and is completed on time. 3 critical aspects of software development: studying alternatives, identifying risks, and resolving them. These factors play a crucial role in ensuring that projects are successful, efficient, and delivered within constraints like time, budget, and technology. 1. Studying alternatives relative to objectives and constraints. Before starting a project, developers must explore alternative solutions to determine the most effective approach. These alternatives should align with the project's objectives while considering constraints such as cost, time, and available resources. For example, if a company wants to develop a mobile payment app, they must decide between building a custom app from scratch, offers full control but requires more time and money, using an existing platform, e.g., integrating with PayPal APIS, faster but may limit customization. Outsourcing development to a third party reduces workload but may introduce security risks. Each alternative must be evaluated based on feasibility, efficiency, and risk factors before choosing the best one. 2. Identifying risks in software development. No project is free from risks. Identifying them early helps teams prevent failures and reduce costs. Some common risks include red circle lack of experience. If the development team is unfamiliar with a technology, they may struggle with implementation. Red circle new or unstable technology. Using the latest technology sounds exciting, but it may be untested or unreliable, causing unexpected failures. Red circle tight schedules. Unrealistic deadlines can lead to poor quality code and burnout. Red circle: poor development process, lack of proper planning, unclear requirements, or poor communication between teams can lead to costly mistakes. Ignoring these risks can lead to project delays, budget overruns, or complete failure. 3. Resolving risks, making smart decisions. Once risks are identified, the next step is to assess their impact and take action. One key question developers should ask is: light bulb. Is it worth continuing system development, or will we lose more money and time? Here are ways to resolve risks. Checkmark: training and skill development. If the team lacks experience, investing in training or hiring experts can bridge the gap. Checkmark: prototype and testing. If using a new technology, building a small prototype first helps assess its feasibility. Checkmark: adjusting timelines. If deadlines are too tight, project managers should negotiate realistic timelines to avoid quality issues. Checkmark: process improvement. Establishing better communication, documentation, and testing practices ensures smoother development. Conclusion: in software development, careful evaluation of alternatives, identifying risks, and proactively resolving them can make the difference between success and failure. The best developers are those who think ahead, make data-driven decisions, and adapt to challenges efficiently. Spiral model can help ensure that your project is successful and runs smoothly. Let's explore the scenarios where the spiral model really shines. 1. When the project is large and complex. The spiral model is particularly beneficial for large and complex projects. If your project has many moving parts, requires multiple teams, or involves sophisticated systems, the spiral model provides the structure and flexibility needed to manage these complexities. It allows you to break the project down into manageable phases or spirals, each one focusing on specific aspects like design, risk analysis, testing, and development. This iterative process makes it easier to adjust as the project evolves, ensuring that everything aligns with the overall objectives, even if the requirements change over time. 2. When you need to focus on risk management. The spiral model is renowned for its emphasis on risk management. If your project involves high levels of uncertainty, technical challenges, or potential obstacles, such as new technologies, untested methods, or unclear requirements, the spiral model's iterative cycles of risk assessment and mitigation are invaluable. Each cycle begins with identifying potential risks, which are then evaluated, addressed, and planned for. This continuous risk management makes it a great fit for projects where you need to proactively identify problems before they escalate. 3. When requirements are likely to evolve. If you're working on a project where requirements are likely to change over time, the spiral model is ideal. This model is designed to accommodate changes throughout the development process. In each iteration, feedback is gathered from stakeholders, allowing for course corrections or refinements as needed. This is especially useful when the full scope of the project isn't clearly defined at the outset, or when the customer's needs may shift as the product is developed. For example, software projects in fast-paced industries or startups, where market demands change rapidly, benefit from the spiral model's flexibility. 4. When you require frequent customer involvement. Another great scenario for using the spiral model is when there is a need for frequent customer feedback. The model's iterative nature ensures that the customer is involved at every stage of development. At the end of each cycle, stakeholders review the progress and provide feedback, which can then be incorporated into the next iteration. This is especially valuable when the customer wants to be engaged throughout the development process and ensure that their vision is aligned with what's being built. It creates a collaborative environment that results in a more tailored and customer-oriented product. 5. When you need high quality assurance. If your project requires high-quality standards or involves critical systems, such as medical or financial software, the spiral model's emphasis on testing and quality assurance is key. Since each phase includes extensive testing, defects are identified early, reducing the risk of delivering a product with major issues. The constant evaluation and refinement of the product throughout the cycles help ensure that the final output meets the highest standards. 6. When you have the resources for ongoing iteration. While the spiral model is highly flexible and adaptive, it requires significant resources in terms of time, expertise, and budget. If your team is prepared to dedicate the necessary resources for ongoing cycles of planning, development, testing, and evaluation, then the spiral model can work to your advantage. It's best suited for teams that can handle the demands of iterative processes, continuous documentation, and frequent risk assessments. If you have access to experienced project managers and risk analysts, the spiral model can truly help you manage complexity and deliver high-quality results. 7. When you have uncertain or changing technology. Finally, if your project involves new or evolving technology, the spiral model can help you navigate uncertainties. Whether you're working with cutting-edge tools, experimental technologies, or emerging trends, the spiral model allows you to test, experiment, and refine your approach with each cycle. This approach is much more forgiving than traditional models because it allows for continuous learning and adaptation in response to technical challenges or innovations. Conclusion. In conclusion, the spiral model is best suited for large, complex projects that involve high risks, evolving requirements, or uncertain technologies. It's ideal when you need frequent customer feedback, ongoing risk management, and a focus on quality assurance. However, it also requires significant resources and expertise, so it's important to ensure that you have the right team and infrastructure in place before committing to this model. An important aspect of the structured evolutionary prototyping model, when to use it. While this model offers flexibility and iterative development, it is not always the right choice for every project. Understanding when to apply it effectively can lead to better software development outcomes. Handling unstable or unclear requirements. One of the best use cases for evolutionary prototyping is when requirements are unstable or need clarification. In many projects, especially at the beginning, stakeholders may struggle to define exact needs. Prototyping allows developers to build a preliminary version and refine requirements through user feedback. Complementing the waterfall model. This model is particularly useful during the requirements clarification stage of a waterfall model. Instead of moving forward with incomplete or vague requirements, evolutionary prototyping can help validate expectations before committing to full-scale development. Developing user interfaces. Another ideal scenario is when the project involves developing user interfaces. UI design is highly interactive and benefits from continuous user feedback. Prototyping ensures that usability, aesthetics, and functionality are refined before final implementation. Short-lived Demonstrations. Prototyping is also effective for short-lived demonstrations. If you need to showcase a concept, test a new idea, or present a working model for approval, a prototype provides a functional representation without the need for full-scale development. New and original development. When working on new, original development, evolutionary prototyping helps navigate uncertainties and allows teams to explore different possibilities before finalizing the design and architecture. Object-oriented analysis and design. Finally, this model is useful for the analysis and design portions of object-oriented development. Since object-oriented programming relies on modular and iterative design, prototyping can help refine class structures, relationships, and interactions before committing to the full system. Conclusion. In summary, the structured evolutionary prototyping model is highly effective when dealing with unclear requirements, developing user interfaces, presenting short-term demonstrations, or working on innovative projects. It also serves as a valuable tool during the early stages of structured development. Methodologies like waterfall and object-oriented programming. By strategically applying this model where it fits best, teams can create better software with improved user satisfaction.